Hi students. In this lecture, I am going to discuss previous year's IIT questions. Let us see first one. Let's see the question given. A beam of protons with a velocity 4 × 10⁵ meter per second enters a uniform magnetic field of 0.3 Tesla at an angle of 60 to the magnetic field. Find the radius of the helical path taken by the proton's beam. Also find the pitch of the helix. So asked for 6 marks in 1986. Let us see. So first write down the given data. So it is given velocity, given protons, velocity. It is 4 × 10⁵ meter per second. Enters uniform magnetic field and field strength is 0.3 Tesla. And angle given 60. Theta equal to 60. So find radius of the helical path taken and also pitch of the helix. Now see carefully. Right. Suppose let us take this is now magnetic field direction B bar and velocity vector makes angle 60 with the field. See carefully. Velocity at an angle of 60 to the magnetic field. Velocity vector is now like this, making angle 60 with the field. This is field. Now we can take for velocity two components. So we are taking for velocity two components. One is along the field, that is V cos 60, normal to field, that is V sin 60. Now you can see, because of this parallel component, it follows a straight line path because of the parallel component. And due to normal component, it follows circular path. Therefore, radius will be R equal to M V sin 60. Okay. So M V sin 60 upon V. And now we have to substitute values in this. Given it is a proton and mass of proton is 1.6, 1.67, 10 power minus 27. And speed is given 4 × 10⁵ sin 60 √3/2 upon BQ. B value 0.3 Tesla and a charge of proton, it is 1.6 10 power minus 90. Okay. So now we have to simplify this. Then you are going to get 1.2 10 power minus 2 meter. Okay. So it is a direct one. Next, we have to focus the pitch of the helix. So here, because of this parallel component, it follows now straight line path. That means combination of circular path and straight line. That is now helical path. And we have learned that pitch equal to, it is magnitude of displacement along the field during one revolution, or you can say during one time period. Okay, that is now V parallel into T. Okay, because along this field acceleration is zero, right? So V parallel is now V cos 60. So time taken to complete one revolution. So time period is now 2 pi into m by b. Okay. So now we have to substitute values in this. Then you are going to get 4.37 10 power minus 2 meter. Okay. For example, in the same problem, if you are given like electric field is present parallel to B bar. See carefully. Suppose electric field is present and that is a parallel to B bar. It is a parallel to B bar. And if you want to calculate pitch, see where change comes. Because of this E bar along B bar, acceleration will be, it is equal to, so this is acceleration only because of electric field, that is Q E by M. Okay. Or if I'm taking this field is along x-axis, okay, then acceleration now along x-axis because of electric field. Then pitch will be, then see what we write here, it will be V parallel into T plus half AX T square. Means writing S equal to UT plus half AT square. Okay, that will be the pitch. That means in previous case, it is a uniform pitch. When there is only magnetic field, it will be uniform pitch. That means pitch is always same value. It does not change. But coming to here, that pitch is not constant. So in this, we have taken electric field along the B bar. So pitch keep on increases. So it is now non-uniform pitch. So we may expect question like this also. Okay. Let us see now next problem. Let's see the question given. An electron gun G emits electrons of energy 2 kilo electron volt traveling in the positive x direction. The electrons are required to hit the spot S where Gs equal to 0.1 meter and the line Gs makes an angle of 60 with x-axis as shown. We can see here a uniform magnetic field B parallel to GS exists in the region outside the electron gun. Find the minimum value of B needed to make the electrons hit S. Okay. See how to start. So first see the given diagram. So it is now given this is given x-axis and field is now like this. Given somewhere here it is yes. Electrons have to hit yes. So field is along GS. This is now given gun. Electrons coming out of the gun. And field is now outside the gun. So velocity. Velocity is now along x-axis. Direction of velocity. This angle is given 60. right? So it's almost same as a previous problem given angle 60. So we can take for velocity two components along the field, that is v cos 60. Okay. Next, normal to field. So right now we require only this parallel component. Okay. And if you remember, we have learned that after every one time period, it is going to touch now this line. Suppose I'm taking here. This is now, let us say this is x-axis, or I can say this is y-axis, for example. And magnetic field is now along y-axis. Suppose velocity is now like this. Then see what happens. After completion of every revolution, or you can say after every one time period, this will touch now that field axis. It will touch like this. Okay. It is touching that field axis. Now coming to here, we are taking the same concept. It has to hit this S. So here we can write GS must be equal to integer multiples of pitch, because this is a P, this is also P, this is also P, this is also P. Okay. That means after every revolution, or you can say after every one time period, it is going to touch now this line GS. Therefore, GS must be integer multiples of pitch. Now see what we can write here. GS equal to N into, in the place of pitch, it is 2 pi m, 2 pi m, 2 pi m by BQ. This is now time period of revolution into V parallel. That is now V cos 60. Okay, into V cos 60. So this is giving us pitch. So from this, see what we get B value. So B equal to N into 2 pi M into V cos 60 upon Q into GS. Okay. Now he's asking us, see the question given. So we have to find minimum value of B. So we have to find for B minimum value. You can see in this, G is a constant, Q constant, mass is a constant, V constant. So here except N, remaining all values are constants, right? Therefore, if N is minimum, B will be minimum. That means for B minimum, condition is N equal to 1. Okay, right. Now substitute values in this. So we require V value, and coming to V value, see how to find. Coming to the question, they have given that energy of electrons given 2 kilo electron volt, kinetic energy equal to half mv square, right? And that is given as 2 kilo 10 power 3 electron volt. 1 electron volt equal to 1.6 10 power minus 19 joule. Okay. See carefully, 2 kilo electron volt. And we know mass of electron. So from this, we are going to get speed of electrons. Okay. So if you are making calculation, the speed comes out to be 2.65 10 power 7 meter per second. Now substitute values in this. Okay. Then we are going to get B minimum. And if we cross check, that value comes out to be 4.73 approximately 10 power minus 3 Tesla. Okay. So here the main thing is calculation part. Okay. The remaining is very simple. Let us see now next problem. Let's see the question given. A particle of mass 1.6 10 power minus 27 kg and a charge 1.6 10 power minus 19 coulomb enters a region of uniform magnetic field of strength 1 Tesla along the direction shown in the figure. The speed of the particle is 10 power 7 meter per second. The magnetic field is directed along the inward normal to the plane of the paper. We can see there cross. Cross indicates it is normal to paper, it is into the board. Okay, that is what given here. Inward normal, right? The particle leaves the region of the field at the point F. Find the distance F and the angle theta. And second one, if the direction of the field is along the outward normal to the plane of the paper, find the time spent by the particle in the region of the magnetic field after entering it at E. Okay, let us see now. So first make the given diagram. Coming to first of all the given data, mass of particle 1.6 10 power minus 27 kg, charge 1.6 10 power minus 19 coulomb. And next, uniform magnetic field strength given. Strength is 1 Tesla. Right. And coming to speed, speed is 10 power 7 meter per second. This is given data. Now make the diagram given. So it enters now at E. At E and leaves at F. So leaves at F. This angle is now theta. So coming to here, we are having the field which is inwards. Okay. Now see how to start. So coming to here, the first thing is this angle is given as 45. So this angle is now given as 45. So now you should be very careful here because angle between velocity vector and field vector, it is not 45. Okay, because we can see the field is now normal to this plane. Imagine this is a board plane. Field is now normal to board plane. And here motion is now in the board plane. See carefully. Motion of the particle is confined to board plane. Okay. So velocity is now in the board plane, but field is now normal to the board plane. So between V bar and B bar, angle is now 90. It is not 45. If angle is 90, path will be circle. This is what we have learned, right? Now see, what's the path followed here? I am taking now this direction of velocity as x-axis. And this is a complete our choice. I am taking this as x-axis and normal to that as y-axis. Okay. Now see carefully direction of force on the particle. If you are taking now this charge given positive, therefore, see what I am doing. Focusing on direction of force. F bar equal to Q into V bar cross B bar. Charge is positive. Okay. So I have taken now this direction of velocity is along x-axis. Therefore, V bar, it is I cap. Direction of V bar is I cap. I cap across. This is now minus K cap. So I cap cross minus K cap. Then see what we get. I cap across K cap minus J cap. Here minus is there. It is now J cap. So direction of force, it will be, it is along y-axis. So velocity is now like this, but force is now in this way. That means motion is now, it is now circle, it is like this. It is now circular path like this. So first we are focusing in which direction forces act. From that we can decide how is the path. This is now path followed, okay? This is now path followed. Let me draw once again the diagram. So this is now that line, that boundary, and path of that particle. It is a part of a circle. It is a part of a circle like this. This is now point E, velocity like this, and coming out. Right now, see geometry carefully. Field inwards. Let me draw here normal to this velocity vector. Normal to velocity vector, and here also take normal to the velocity vector. Point of intersection of these normals gives center of that circle. Okay, because velocity is always along the tangent. Now focus carefully here. Let me draw here one normal to this boundary. It is given now this angle is 45. That angle is 45. So now coming to here, this is a 45. You can see this is normal to this line. This is normal to this bound. So between the normals also same angle. So this also 45. I am repeating. This line is normal to velocity. This line is normal to this bound. So between the normals again same angle. So 45. Next coming to here. Given this is theta. If this is theta, this is also theta. Okay. Now see carefully this triangle and this triangle. Both are now identical. That means this length and this length both are same. It is radius of circle. This also same. That means theta must be equal to 45 because same length. This also same length. That means from this diagram we can see that theta equal to 40. Okay. Now see the question what we have to calculate. So coming to the question, find the angle theta. So that we got 45. Next, if the direction of the field along the outward normal, so this part is over. If it is along the outward normal to the plane of the paper, find the time spent by the particle in the region of the magnetic field after entering it at E. Means again question same. The only change is now here direction of field is into the board. Now given it is out of the board. That is the only change. Asking how much time it has spent in the region. Now do one thing. Now in this case, how much time it has spent in the field? Okay, this angle 45. Theta also 45, right? That means this total angle how much? 90. So time spent in the region. So take it as T1, that is equal to pi by 2 into m by b. See here what we are doing. So time period of revolution is 2 pi into m by b. This angle is now 90. That's why 90 into m by b. This is now time spent in the ratio. Now coming to part B, see where change comes. So when it enters at E, since direction of field is outwards and normal to the board. So in the place of B bar, it is here we have taken minus K cap. Now we have to take K cap. That means direction of force will be I cap across K cap. That is minus J cap. That means the force will be like this. Okay. Velocity in this way, but a force will be like this. I will make diagram here. See how that path. It is once again circular path. Okay. So while making diagram, we should be very careful. It enters at E. It enters at E. This is E. Now we got forces now along negative y-axis. Okay. That means now circle will be. This is now direction of velocity. Circle will be like this. Okay, it comes like this. And velocity outwards, coming outwards like this. Now see carefully, once again geometry. I'm taking here normal, same as this first one. See here we have taken normal to this velocity vector. Here also normal to the velocity vector. Taking same thing. Take normal for this velocity vector. So take normal. Again take normal for velocity vector at this point. This is now center of that circle. Okay. Next, now see what we can do here. I'm taking here one normal to this boundary, and we can see this angle is 45. Again, I'm taking same logic. This is normal to this line. This is normal to this line. So between the normal same angle, this is 45. So this also 45. Why? Because this length and this length both are same. And this length same for both, right? For both triangles. So this also 45. So 45, 45 it is 90. So this angle is now 270. So time spent, that is equal to, I'm taking as T2, that is equal to 3 pi by 2. Because this is 90. Remaining is now 270 into m by b. This is now time spent in that region. Okay. So here, the first thing we have to focus is this 45. Remember, between velocity vector and field vector, angle is 90. It is not 45. Next, we are focusing direction of force. Depending on that, path will be. It is now here like this. In second case, path is like this. In both cases, it is circle only. But here, it is spent less time in field. Here, it is spending more time. If they ask like, find relation between T1 and T2, we can say T2 is 3 times of T1, right? So I hope you got clarity.